It's Monday, January the 29th. 1 month is almost already over in the new year. Let's continue our unit on dilations. First, I want to recap what we've already been over. I want you to think to yourself and look in your notes and think about what you know about scale factors. I want you to think about and define enlargements, reductions. I want you to visualize and think about the algebraic rule for dilations. What does that look like? And describe how you would compute the dilation on a figure. Those are all the things that we've been over. Today, let's go over some star examples of the material we've covered. Triangle M and P is graphed on a coordinate grid with vertices M, N, P. Triangle MNP is dilated by a scale factor of U, with the origin as the center of dilation. To create triangle MNP prime, which ordered pair represents the coordinates of the vertex P? Well, what two can we eliminate immediately? Actually, there's three, but let's start with two. Based on what we know we have to do with the scale factor to get the new triangle, we can eliminate. Think to yourself, and I'll pause for a second while you figure out which two I'm looking for. Okay, the first one we can eliminate is A, because they are taking the vertices and adding them to the scale factor. C, they're adding them and they're doing some sort of division as well. 1 divided by the scale factor plus 6. That's not right either. The third one is B. They're dividing the vertices by the scale factor. What we learned and what the rule is to dilate a figure, you multiply the x and the y by the scale factor. In this case, it's u. So 6u would be your x, and negative 3u would be your y. So the correct answer is D. This was on last year's test. Here's another one. Quadrilateral FGHJ was dilated with the origin as the center of dilation to create the new quadrilateral. Which rule best represents the dilation that was applied to create the new one? Okay, so first you need to figure out what is the scale factor. We can do that by looking at we can do that by counting, looking at points, whatever you prefer. So we know this is our original figure, and these with the prime marks, this is our dilation. So we can divide the new figure by the old figure. Let's see if we can count some sides here. Looks like we can count this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this one's 1, 2, 13, 14. So 14 divided by 10. What do you get when you take 14 divided by 10? You should get 1.4. So that will give us H. Another way to look at these answers is like the question before. We know G is not going to work because they're adding that. We know J is not going to work. They're adding and subtracting. F, they are multiplying, and H, they are multiplying. So you just need to figure out which scale factor is correct. This one has to do with the circle, and we've not gone over how to count the squares for a circle. So I'll do that with you now. Circle 1 was dilated with the origin as the center of dilation to create circle 2. So this is our original, this is our new circle. Which rule best represents the dilation applied to circle 1 to create circle 2? So we need to do the scale factor. We can eliminate H because they're adding. We can eliminate J because they're subtracting. We want the one that multiplies, which is either F or G. We just need to figure out which one of these scale factors are correct. I'm going to let you look at that for a minute before we go over the answer. Okay, to get the answer, we know to get the scale factor, you need to divide the new figure by the original figure, or the new figure by the old figure. So let's take this point here. We see that this is 0 and 8. Or you can take this point, which is 8 and 0. And divide it by the old point, which is 3 and 0 here, or 0, 3 here. Which one looks like that? Which is in that format? The answer is G, 8 over 3. And it doesn't matter which one you use. Here's another one. Figure S is the small arrow, was dilated with the origin as the center of dilation to create T, the large arrow. Okay, which rule best represents the dilation that was applied to figure S to create figure T? Well, what can you see by this picture? This is the original figure, this is the new figure. Hopefully you can see that figure T is bigger. So the rule is the scale factor needs to be larger than 1. Based on that, what two answers can we eliminate? That's correct, C and D. So we have A and B to look at. So we can let's take this point here, 0 and 3. That is the original figure. And the new figure is 6 and 0. So we divide the new by the old. 6 divided by 3 is 2. So your answer is A. Want to look at some properties of dilations review. Orientation of the vertices is the order in which the vertices are labeled, clockwise or counterclockwise. Using this definition, we know orientation is preserved using translations, dilations, and rotations. It is not preserved for a reflection. Orientation of a figure is the direction in which the figure is placed in the coordinate plane. It is preserved by dilation and translation, but not by reflection or rotation. These two turn around or flip. Since dilations change the size of the shape proportionally, the shapes are no longer congruent or, in other words, the exact same. Dilations and measurements. This is the new stuff. How do you describe the effects of a dilation on linear and area measurements? The perimeter is multiplied by the scale factor k, which is the scale factor. Area is multiplied by scale factor squared, so k squared. Whatever your scale factor is, you would square it to get your area. Let's do an example. Find the perimeter and area of the image after dilating the figures shown with the given scale factor. Okay, this slide I'm going to take you through using the formulas for area and perimeter. Then we're going to do it on the next slide the easy way. So you have this example. You have a scale factor of 5. You have this side is 3. This side is 3. Okay, so if this is 3 and this is 3, we know the perimeter of this figure is 12, because 3 plus 3 plus 3 plus 3 is 12. We know the area is 9, because 3 times 3 is 9. So let's dilate the figure by given scale factor of 5. Step 1, dilate the figure by 5. So the sides will now be 15 and 15. So you can add those up, 15 plus 15 plus 15 plus 15. You're going to get 60 for the perimeter of the new figure. For the area, it would be 15 times 15, which is 225. So you can do it that way. Or you can do it using this here. And let's do that. Let's do that now. Let's do an example using rules from slide 29. Okay? Same question. Find the perimeter and area of an image after dilating the figures with the scale factor of 5. Here's step 1. Multiply this perimeter by the scale factor. So 12 times 5 is 60. See? It's the same as this one. And to get the area, you multiply the area, which is 9, by the scale factor of k squared. In that case, k squared is 5 squared, because the scale factor is 5, which gives you 25. 9 times 25 is 225. See? Same as this one. You can use either method to find the area and the perimeter. We're going to use this method going forward. Now it's your turn. Find the perimeter and area of the image after dilating the figures shown with the scale factor of 3/4. The current sides are 8 and 16. Current perimeter is 48. Area is 128. So give me the perimeter and the area after you dilate the figure. Pause the video while you can do your math. Okay, hopefully you got for the perimeter of the new shape 36 and the area is 72. Let's do one more. A rectangle has a width of 3 centimeters and a length of 4 centimeters. This shape is dilated with the scale factor of 2. Find the perimeter and the area of the dilated figure. So first you would need to figure out what the perimeter is and the area of this, and then dilate it by 2. Pause the video and then resume playing so you can check your answers. Hopefully you got the perimeter is 28 and the area is 48. That does it for today's lesson. You may now get your homework and complete that. Thank you for watching.